Hello and welcome back to Calculus 2. After the lively discussion of lives and what to do, we are going to transition into properties of power series. So now, we talked about the power series and I said that you have a variable x in it. Now, you also know that you have geometric series. Now, consider number 2 and consider variable x. See, number 2 is set. It's number 2. We understand. Mathematical abstraction shows quantity, quantity is 2, and so on. 2 trees or 2 o'clock, so we understand what 2 is. But then you have x. X is a variable, and it can take on any value. It can take 2, but it can also take 1/2. Now, why is that important? Well, it's important because if I write my geometric series with 2 to the k, starting from 0 to infinity, you will look at that series, and because you are great students who already memorized geometric series, you can tell me immediately the fate of that. What's the fate? What's the fate of this?
Fate?
Yeah, fate. What is it? Yeah. So what is it? Diverge, exactly. So this diverge because r is equal to 2, which is bigger than 1, right? But now I'm going to write summation of x to the k. Aha! I got myself a power series over there. Converge or diverge? Converge or diverge? Both, right? Schrodinger's cat is dead and alive at the same time. So, is it going to converge or diverge? Well, it depends on when you do the measurement. How do you know if the cat is dead or alive? You open the box and you look, right? The wave functions collapse to one of the two states. So, the cat is dead and alive at the same time until you look at it. Well, in this case, this particular problem converges and diverges at the same time. Only when you give me the value of x, I will be able to determine whether it converges or diverges, right? So it's not conditional.
But conditionally,
no.
It could be converged.
No. So the fate of this power series, so now I have to go and say, if x is between 1 and -1, it converges, otherwise diverges. So you see that we actually have an interval for x values under which it converges, otherwise it diverges. And that is what we call interval of convergence, and then half of that interval is the radius of convergence. So power series, do they converge or diverge? Both. We don't know until the value of x is revealed. But we can come up with the interval of all values of x that will make my power series converge, and then also the rest is diverge. So now, to understand this, we take a look at 3 series given in your textbook and decide whether these converge or diverge. Now, the best thing here is that we are always going to use ratio test so to determine this answer. All right. So let's talk about first one. So we look at this first series. It's a power series. They all are because they all have x in it. And we go and say, let's use the ratio test to check for convergence. So ratio test says your ak is x to the k over k factorial, and your ak plus 1 is x to the k plus 1 divided by k plus 1 factorial. Ratio test is limit k goes to infinity. Then I have the ak plus 1. We peel off 1x, so we have x to the k. We peel off k plus 1. We did this yesterday. And we have now our k factorial times k factorial over x to the k. These guys now cancel. And we got ourselves. Now, don't forget the absolute values. It's very important, right? So now we got ourselves limit k goes to infinity of absolute value x over k plus 1. Now, limit is the operator which operates on k's in this case. So x is a constant in the eyes of the limit, and you can kick constants outside. So this is equal to absolute x times the limit of k goes to infinity of 1 over k plus 1. Now this is equal to absolute x times 0, which is 0. Now 0 is always less than 1. So we see that because of this, right, power series converges for all values of x. It doesn't matter what you pick. If you pick negative 10 times 0 is going to be 0. That's less than 1, converge by a ratio test. If you pick a million times 0 is a 0, less than 1, converge by ratio test. So for this particular problem, every single x that you pick is going to make it into a convergent series. Now look, as soon as you pick x to be a number, your power series becomes the regular chapter 8 series. Bueno? So power series are power series because they have x. But as soon as you pick a value for that x, well, you have no x's anymore. It goes back to chapter 8. So now we discovered that this power series would be convergent series for any x value that you pick. Now the next problem that has this alternating negative 1 to the k, as you can see, is centered at 2 because it has x minus 2 in it. And you also see divided by 4 to the k from 0 to infinity. We do a ratio test again. We always do ratio test. You can also do root. It's rare, but the only other alternative to ratio test for power series would be root test. Okay, so we have our ak as negative 1 to the k, x minus 2 to the k divided by 4 to the k. And ak plus 1 is negative 1 to the k plus 1 times x minus 2 to the k plus 1 divided by 4 to the k plus 1. Ratio test. So limit k goes to infinity. We are dividing ak plus 1 by ak. So I will immediately, do all the algebra to flip and peel. First of all, do I write negative 1 to the k? No, there's absolute value. It's going to die. So who cares about it? Negative 1 to the k doesn't need to go in there at all because we have absolute values. So out with that. I have x minus 2 times x minus 2 to the k divided by 4 times 4 to the k times 4 to the k minus 1 to the k out, x minus 2 to the k, close absolute values. Cancel, 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 cancel. What are we done? What are we left with? K goes to infinity of absolute value of x minus 2 divided by 4. You see any k's? So just drop the limit. Limit has nothing to do there. This is a limit of a constant. The answer is a constant. So we just have x minus 2 over 4 in absolute values. Now, guys, this is where your absolute values matter and why I told you don't play with fire, not to write them. Condition for convergence, and you are looking for interval of convergence, is for this to be less than 1. Your job is to solve this inequality, right? So this part over here is we set this less than 1 because we want convergence. But now when we set that to -1, we have to solve the inequality. So I have x minus 2 over 4 in absolute value less than 1. Now, if you know your algebra, you will have -1 less than x minus 2 over 4 less than 1. So that's that. Multiply by 4 everywhere. So you get -4 less than x minus 2 minus less than 4. And then add 2 everywhere for -2 less than x less than 2. So, 6. Yeah, 6. Thank you. 6. So now, interval of convergence is -2 to 6. What does this mean? This means that any x value that you pick between -2 and 6 will transform this power series into a convergent power series. So if you use -1.9, if you use 0, if you use 1, if you use 5, right? Any of those numbers between -2 and 6, and you plug that number here, this will become a regular chapter 8 series, and it will be convergent. Anything outside of that range will immediately make it divergent in chapter 8. So we went through the power series and we calculate. Now the next one is a radius of convergence. Radius of convergence is simply you have -2 on this end, you have +6 on this end. Where is the half? Well, half is a 2 because you have 4 units this way and 4 units this way for a total of 8 units between -2 and +6. Now, that should be common sense that the center of this is at 2 because centered at 2. We started a problem that was centered at 2, so your answer better be centered at 2. Otherwise, you are doing some very, very suspicious mathematics. So now, what is the radius? Radius of convergence is going to be r equals to 4. So halfway, one way. Well, we know the radius is a half of the diameter. Diameter is the whole length, so radius is half. Now you might ask, like, why is this called the radius of convergence? Because we are on the length. The answer to that is Lorentz series in complex variables, and those series are two-dimensional series. So when you have the real axis and imaginary axis and you have the series everywhere in there, there is a disk, right? And now you see the radius of convergence, which is what you want to know. Since you are in a one-dimensional space right now, there is your one-dimensional space with all of the values there. So we can also have a radius on 1D. Just keeping consistent with names. Radius. There we go. So now, the first example we did, we said power series converges for all values of x. So your interval of convergence is infinite. That means negative infinity to positive infinity. And your radius of convergence is r equals infinity. That means any x goes all the time is convergent. The next example, we figured out, after all these calculations, that radius of convergence is now 4, and the interval is 4 units to the left and 4 units to the right to the center. So we got that. The third and the last problem for today is k factorial x to the k from 1 to infinity. So that's the last problem. What do? Ratio test. So ak is k factorial x to the k, and ak plus 1 is equal to k plus 1 factorial x to the k plus 1. Now this does look like a divergent thing, right? It looks like it should diverge because there's no denominator to pull anything down. Hold on. Limit k goes to infinity of, we peel off k plus 1, and then we just have k factorial, and then we peel x, and then we have x to the k divided by k factorial x to the k. Kill. There we go. We have limit k goes to infinity, absolute value k plus 1 times x. That's all I have. Now, the limit only operates on k's. So you can kick x with the absolute value in front. So we have absolute x is equal to, times limit of, you don't need absolutes anymore because k is always positive. So k plus 1 as k goes to infinity. So you might be tempted to say infinity, but x could be 0, right? Which makes this converge. So now it converges at a single point. For x equals 0, it converges, and it diverges for all other values of x. So this is going to have two answers: infinity or 0. 0 is when x is equal to 0, and when x is not equal to 0, you have an infinity. So you have divergence, right? So now, what we claim for this problem is that the interval of convergence is actually just a single point, x equals 0, and the radius of convergence is r equal to 0. It's just a single point. It's no length on the radius. So these three problems are very good problems to see all of the possibilities that you guys have as you're dealing with power series. Possibility number 1 converges for any x you think about, right? Think of. So that's that. The next one has a set interval of convergence, which is the interval between two numbers. And the third case converges at the single point, right? And you have to figure out what that point is. It doesn't have to be 0, right? Could be it converges only at 1, or it converges only at 100. Could be any point.
So they always converge at some point? There's never any absolutely divergent power series?
Yeah, they are. But we are looking for...
You just said 3 cases.
Yeah, 3 cases for convergence. I don't care about divergence series unless I'm designing explosives and things like that. It's called mathematics of detonation. It's a field of mathematics. So you get to work for the companies that do the defense. Yeah. So they actually have the mathematical research, and they do care about divergent stuff, right? Because that's what the explosion is. But if you are designing anything that is not that, right, you only care about convergence. So the 3 cases that we covered, they only cover convergence, which is all we care about in engineering, right? So converges everywhere, converges on the interval, converges at a point. And sure, the 4th one diverges everywhere, but as I said, we don't care about that because it's, for our case, it's useless, right? For you know, all applications other than detonation.
No, I just want to get on the test.
My boy. Bye.